Hello! In today's video we will talk about two fundamental electrical components, diodes and capacitors. Let's start with diodes. A diode is a two-terminal electronic component that only conducts current in one direction. The orientation of the diode is usually marked with a gray bar at one end. That end is the output of the diode. Ideally, a perfect diode has zero resistance in one direction and infinite in the other. In practice, this is not achievable, but real-world diodes still work sufficiently. Diodes are used to restrict current flowing in the wrong direction in a circuit. A common example is DC motors. When you stop supplying power to a DC motor, it might cause a negative voltage spike. To avoid risking breaking your other components, such as the Arduino, a diode is used to stop the spike in voltage. It's also a good idea to connect a capacitor in parallel with a DC motor. Let's find out why. Like diodes, capacitors are two-terminal electronic components. Capacitors store and release electrical energy in an electric field and can be thought of as tiny batteries. Usually, the negative leg of a capacitor is the one marked. Depending on the capacitor type, it can be a black line or an arrow. Capacitors have many use cases, such as smoothing out current spikes, turning AC voltage to DC voltage, or filtering signals. As mentioned earlier, it's a good idea to connect a capacitor in parallel with a DC motor. This is because of the capacitor's ability to smooth out the supply current. This leads to a more constant motor speed and current drawn from the power supply. We are now demonstrating an example circuit using a capacitor and diode as circuit protection when driving a DC motor. To follow along, you will need a breadboard, some hookup wires, a diode, a capacitor, a DC motor, and an external power supply. We are using a 9-volt battery. First, connect the DC motor to the breadboard. Connect both the diode and the capacitor in parallel with the motor. The diode should be oriented from the motor's ground to its power. Lastly, connect the external power supply to the corresponding terminals of the motor. Note that the motor will draw the maximum current from the battery as there is no control component in the circuit. A diode consists of one p-type and one n-type semiconductor. P stands for positive and means that the material has spaces in its electron band. N stands for negative and means that there is an excessive amount of electrons in the material's electron band. If no current is fed to the diode, some of the electrons from the n-type material cross the junction and fill the holes in the p-type material. This causes the atoms to become charged ions with an electric field between them. The electric field exerts a force on the electrons opposing their tendency to cross the p-n junction. This creates an equilibrium state. When an electric current is fed to the n-type semiconductor, the electrons are pushed towards the p-type semiconductor's holes. The holes are filled and the current flows through the diode. If the current is reversed, the holes of the p-type semiconductor are drawn away from the n-type semiconductor, and thus they can't combine. Essentially, there is no current flowing through the diode. A capacitor consists of two conductive metal plates which are separated from each other by an insulating layer. This layer is called a dielectric and blocks DC current from flowing through the capacitor. Instead, there is a potential difference, a voltage, present between the plates when current is fed to a capacitor due to the electric field. When the voltage in the circuit drops below the voltage between the plates of the capacitor starts to discharge. This resists changes in the circuit's voltage until the capacitor's voltage matches the one in the circuit. The capacitor's ability to store an electrical charge onto its two plates is measured in farads and is called the capacitance of the capacitor. The capacitance depends on the surface area of the plates and the distance between them. That's everything for today's video. Thank you for watching and see you in the next one.